All right, welcome back. We're talking pre-calculus B, perpendicular vectors, okay? And kind of like the theme song of the summer, all about the base. It's all about the torque this time. So torque is basically when you're turning an object, it's the force being applied on the object, okay? So it's not the rotational, it's actually a perpendicular force to that. Okay, so there's a couple things you need to know, and we're going to start off with the big ones. Okay, so let's pick a nice color. Let's go red. Okay. All right, so inner product or dot product, okay, will actually tell you if two vectors are perpendicular or not. Okay, and this works for both three-dimensional and two-dimensional. So if vectors A and B are listed as vector A1, A2, and vector B1, B2, then A dot B, okay, and I can't remember if this is alt like 7 or something. I can't, oh man, I always forget the number. Anyways, if you look at the alt code for the multiplication sign, that's what it is. Okay, A dot B is A1, the first coordinate of the first vector, times the first coordinate of the second vector, plus the second coordinate of the first vector times the second coordinate of the second vector. Okay, and you just add those together, and that will just do it. Now, if they are 0, then you are dealing with perpendicular vectors. Okay, all right, same goes for three-dimensional, except instead of just the first two, you would actually have a third coordinate that you would add it all up. Okay, so this is how you test perpendicularity. Okay, if two vectors are perpendicular or not. Okay, now if it's not 0, then you know it's definitely not one of those. It's not perpendicular. Okay, so it's just, also another thing is they call it normal. So when you're kind of looking at this, you're going to be looking at, are these vectors normal? Okay. All right, and it's not like normal, like you know, are they of normal height or weight or something? It just means normal means perpendicular or not. Okay, so that's just a test. So when you're using the dot product, you're just testing to see if two are perpendicular or not. Now it's going to be really tricky in 3 dimensions, so don't worry about the fact that you might get two vectors that are not perpendicular. Okay. Now, in 3-dimensional space, we can find the torque of two vectors by finding a third perpendicular vector. Now, this is called cross product, okay? So you have to understand cross product is going to be producing. You're going to be given two vectors. They're acting on each other. They don't have to be perpendicular. But when they're acting on each other, you're actually creating the cross product of two vectors creates a third vector that is perpendicular. Okay, so it's almost like you're creating your own answer towards the inner product or the dot. We just call it dot product. I don't want to call it inner product or anything. Dot product. Okay, so now cross product you do have to use with 3-dimensional vectors. So if you're given a vector A and vector B, and it's A1, A2, A3, and B1, B2, B3, okay, it is A cross B, and you do read this as cross. Okay, and then you're going to do these good old-fashioned determinants, or is what you should start calling them, eigenvalues. Okay, so we're going to find the eigenvalues. Now, if you notice, I already have signs lined up in here, and I have letters in here. This is based off of the unit vector and everything. So when you're looking at the unit vector, like for example, if you were looking at something like this, 3i plus 5j minus 7k, okay, that just means the vector 3 comma 5 comma negative 7. Okay, so that's just how you represent it. You know, this is just the unit vectors right here. Okay, so you do the determinant of A2, A3, B2, B3 for the I portion, then for the J portion, A1, A3, B1, B3 for the J, and A1, A2, and B1, B2 for the K. Okay, and you do the determinants of this stuff and just work with it as is. Okay, Now, another thing that also is set up with this is actually just kind of like when you're finding the determinant of, it's very similar to finding a determinant of a 3 by 3 matrix. Okay, so just so you know, that's just the way it is, and it's just how it's going to be. Okay, so just be ready for that. So please understand, this is very similar to the determinants of a 3 by 3 matrix if you had to do it by hand. Okay, all right. All right, but that's pretty much it for cross product and inner product. Just remember, inner product or dot product is testing to see if they're perpendicular or not. And cross product only works with three-dimensional. Cross product produces a third perpendicular vector. Okay, so cross products make perpendicular. Dot products test to see if you have perpendicularity. Okay, and dot products, once again, you can use both two-dimensional and three-dimensional. Okay, all right, that's it for dot product and cross product. I'll talk to you guys later. Bye.